Today we're going to go over combustion and terms and concepts related to it. So if you look at the board behind me, we'll just start at the top here. When we talk about auto-ignition temperature, when we think about auto-ignition temperature, we're talking about the temperature at which a substance is so hot that it just bursts into flame without need for an ignition source. As things get hotter and hotter, most substances, though not necessarily all, have a point at which when they reach that temperature they will, if there is oxygen or other medium in which it can burst into flame on its own without the need for an external source of combustion, heat, fire, anything like that. It just on its own, spontaneously. And so it would be tied into number 5 here, spontaneous combustion, no source of ignition. When we think about things that don't need a source of ignition and yet burst into flame, we can think in terms of maybe a compost pile. As the compost pile sits there, it's got hay and other things in it probably. It's strongly insulated, and there's fermentation going on inside of it through the bacteria, which is generating heat. And as the heat rises because of the insulation, there's nowhere for it to go. It eventually reaches a temperature at which ignition can take place without an outside source, and it bursts into flames. And so sometimes people do have compost piles that go up in flames because of the spontaneous combustion medium, the fermentation by the bacteria, raising the temperature, it's well insulated, and then boom, up it goes. When we think about combustion, we have certain types of reactions. Exothermic reactions are those that give off heat. They generate heat and force it out, sometimes light, sometimes noise in the form of explosions, but exothermics give off. Endothermic absorb or take in heat in these kind of reactions. So there is a heat transfer taking place here. Exothermic forcing it out, endothermic pulling it in, absorbing heat inward. When we think of endothermic reactions here, you can think of these sports medicine instant cold packs that has a chemical reaction inside of them that gets very cold very quickly. This is an endothermic reaction. So when we think about heat transfer, which is very much a part of combustion, we need to remember that what's going on is within the way physics works now, thermal equilibrium is always trying to be sought. So if there's something that's warmer next to something that's colder, the general motion will be that the warmer temperature will move towards the colder temperature until these reach equilibrium. If you think here of a rod that's been superheated on one end and is room temperature on the other end, what's going to happen then in conduction with this thermal transfer is the kinetic energy from the rapidly moving molecules and atoms down here on the hot end running into the colder ones, transferring their heat and energy that way. And so the heat moves down from the hot end towards the cold end, eventually reaching a place of equilibrium where this loses its heat, this gains the heat, and then they match. So heat transfer is very much a part of combustion. Conduction being one of those things, direct molecular transfer of heat until thermal equilibrium is reached. Another form of heat transfer is radiation. This is electromagnetic wave transfer of heat. Here we need to think in terms of the sun, which gives off electromagnetic waves or radiates radiation, and it heats the earth. It communicates it through the medium of a vacuum, space, but it still arrives here in the form of heat transfer, radiation, as it warms the earth and strikes the earth. So that would be a form of heat transfer radiation. And then convection. Convection is heat transfer through a fluid medium. Now when we say fluid, we don't automatically mean liquids. Fluids are also gases. So a fluid medium is a gas or a liquid. So you can get convection currents in air as well as in water. What you have then is heat is applied to the fluid, either gas or air, and as the fluid is heated, it gets less dense and warmer, and so it rises, causing the more dense, colder fluid then to move downward, and you get a circular motion. If we think in terms of boiling water, you can actually watch as it seems to churn up from the bottom. The heat source is there. The hot water becomes less dense, lighter, comes to the surface. The cold water sinks down, is heated, and comes up again. You can think in terms of air as well. Hot air, less dense, lighter, rises, cold air, more dense, heavier, sinks, is heated, and sent around. So you get these circular convection currents. So these are the main things to keep in mind around heat transfer: conduction, direct molecular radiation, waves, convection, this circular motion through a fluid medium, gas or liquid. We talked about spontaneous combustion in your compost pile. under auto ignition temperature. And then we've got hypergolic reactions here, or combustion. Basically, that's a substance, when brought into contact with another substance, that immediately ignites without an ignition source necessary. It's just that type of reaction. And this is what they do in rocket engines. They have two separate substances kept in different compartments, and then they are injected into a third compartment at the same time. And when they meet and react, you get combustion automatically without an ignition source, which then they use to propel the rocket upwards. So hypergolic substances are those that ignite or combust when brought into connection with an oxidizer. So this substance brought into an oxidizer immediately combusts, and of course you get rocket explosions directed beneath the rocket, which sends it up. So hypergolic combustion. Well, this has just been a brief overview then of things related to combustion, some of the concepts, some of the vocabulary